This is an introduction to the graphs topic in Extension 2. In this section, we're going to quickly review some of the concepts from 2-Unit and Extension 1 before moving on to some more complex ideas. So just before we start, a reminder that obviously as questions get more complicated and the ideas get more tricky, it would be a good idea to have access to a graphing software so you can double check your results, and also they provide an opportunity to have a practice of the concepts and have a look at what the effects of some of the things we're going to do are. Okay, just a reminder that in any question, if you are asked to sketch, you need to make sure they're at a reasonable size. Don't do anything smaller than a third. We're looking at a third to a half a page. Half a page, especially for graphs, I highly recommend for the HSC. Use appropriate scales. A lot of the time it's just a sketch, but try to make it look reasonable and sensible. Wherever you can, you need to include intercepts. Obviously, sometimes x-intercepts are pretty tricky, and if they are very hard to find, then you can leave them out. But again, you have to make sure if, for example, you know the x-intercepts are going to be negative, then you place them in the right place. When you can find them, use exact values. If you can, never use decimal. So if it's square root of 2, put square root of 2, not a decimal version. And you have to make sure you label any asymptotes, critical points, turning points, points of inflection. Okay, let's move on. So some of the things we should know from before. These are things you need to produce quickly, and they're considered to be basic. So linear function, general form and gradient intercept form, quadratic function, cubic. So you need to know what a cubic looks like as you approach from left to right. What happens if A is positive and A is negative? A quartic function, again, you need to know what it looks like as a general rule. The rectangular hyperbola, well, we'll just cover that in conics, so hopefully that's fresh in your mind. The equation of a circle, the center isn't 0, 0. Exponential functions, log functions, all your trig functions. So you need to know the effect of the amplitude, the coefficient of B, adding a C, and adding a K. So just reminding you that the amplitude makes the graph taller, essentially. B, if it's greater than 1, what's the effect? It makes the graph squished up. If it's less than 1, it stretches the graph. Obviously, we're talking about absolute values. And K, well, that just shifts the whole graph up or down. Inverse trig functions you need to be very familiar with, and we've just covered that. Functions of the form y equals a half, y equals x to the power of a half, and y equals x to the power of a third. Now, it's important to know what happens with these graphs as we approach x equals 0. And we're specifically interested in the derivative or the gradient. If you think about the graph of y equals x to the half, that's the inverse of the graph of y equals x squared. So that's the parabola reflected about the line y equals x. Now I'm going to move things around here so we can have a better look at what happens there. If I can. There we go. Okay, so the graph of y equals x to the half. Try again. looks like that. And around this area, and I just lost my graph, try again. Around this area, we end up with a vertical tangent, which has a gradient 25, and that's significant. That brings us to the end of the introduction to the graphs topic, covering content from 2 Unit and Extension 1.